on my finger, you wouldn't see it. It's the size of a speck of dust. It's actually on a US dime, which is quite small. And you can see that it's not much bigger than the date stamp on the US dime. But what's significant about this chip is this is not some commoditized chip. This is a full-blown 32-bit microprocessor with significant GPIO. I mean, this will run full-blown operating systems on it. Think about what happens when you use this type of compute and embed it in things, in clothing, in livestock, in corn. I mean, how does it change how we sense and compute? This is the M3, the Michigan Micro Moat, and this is a, there we go, this is a sensor platform. So it's actually a stacked chip. We've broken it apart for you so you can see it. This is now on a US penny. And you can see it's not much bigger than the date stamp on the US penny. At the bottom we have the CPU, then we have the radio, and then we have the control unit. This sensor platform, which is wireless, you can talk to other motes of its like. It's smaller than a grain of sand. So you get the idea. And this is what's happening now. This is not 2023, this is 2013. This is the type of technology that's under development now. Consider this technology a decade from now. You remember my numbers from before. Not only will it be 32 times more processing power, but it'll be 100 times smaller than this. I mean, this is pretty small already. Imagine this 100 times smaller. How does that start to change how we instrument our world and how we add processing and communication to everything? It changes everything. This is a device called the Node. And let me quickly demonstrate this to you. This device here is from a company called Variable Technologies, the Node. And the Node is a powerhouse of sensors. So this device here can measure different types of gases, carbon monoxide, and so on. It has an accelerometer, a gyroscope. It can measure radiation. It can measure color. It's got a whole host of sensing capabilities in a tiny platform, about $149. If I point it, for example, if we look at the iPod here that I'm talking to, it communicates to a smartphone or a smart device over low power Bluetooth. It's showing that the ambient temperature in the room is 73 degrees. If I point it at this, let's point it at something hot. Let's point it at this light. Oh, again, it helps if the light is on. There we go. You can see that the temperature now is increasing significantly. This will read about 10 readings per second. The point is the amount of technology in a device that size. This thing has a complete open API, so you can now write applications that react based on sensory information. This type of technology at this price point would have been impossible a decade ago. And you think about where we're going to go with this a decade from now, possibilities are significant. By 2023, you take these technology progressions and you put them all together. By 2023, the power of a smartphone today will fit inside the frame of your glasses. Not alongside, not in your pocket, not anywhere, but inside the frame. And you think about what's inside a smartphone today. Accelerometer, gyroscope, multiple radios, processing, storage. All of that technology is going to get very, very small. How does that change how we start to connect and sense and add new types of things to the Internet of Everything? It changes everything. So things that are impossible today will be commonplace tomorrow. So I've given you a quick definition of IoE. We've talked about some of the enabling technologies. Now let's take a look at what this means. Let's fast forward a few years.